This is R.D. Sharma solution, class 12, chapter 10, differentiability. Exercise is 10.2. Examine the differentiability of the function f defined by this. So this solution will be through f dash x. Till now we haven't heard about or learned about the differentiation, proper differentiation, but differentiability we know. But why we cannot use that differentiability? Because differentiability is fx minus fc by x minus c limit x tends to c. This we already know after all these questions we have done. And in this number line, let me show you the points where we have to check. We have minus 3, negative 2 and 0 and 1. Minus 3 and 1 we cannot check because when we go to the left hand limit for minus 3 we don't get anything. When we go right hand limit for the 1 we don't get anything. So we can only check for negative 2 and 0. Now I'm just going to tell you how do we fail. That's why we have to opt for f dash x. So let us say I'm checking at x equals minus 2. So left hand derivative minus 2 minus h I'll put, because we are just going a bit backwards to minus 2, and x equals minus 2 minus h. So in place of fx I have to use 2x plus 3. And when you put fc, that is f negative 2, this equality sign is here, so you have to use 2x plus 3 function here. So remember why I'm doing this. It is going to fail. I'll show you how it fails. So 2 into negative 2 plus 3 is going to minus 4 plus 3 is going to be negative 1. So negative positive. And we have x minus 3x. Of course, we have to keep it as a negative 2 negative h, minus 2 minus h that is, and minus it becomes plus. So I'm replacing actually minus 2 minus h here. I'm not doing RHD just because I just want to show you what's going to happen. So minus 2 minus h plus 2 in the denominator you get only negative h. In the numerator you have minus 4 minus 2h plus 1 divided by minus h. You are going to get minus 3 minus 2h by minus h. Now limit h tends to 0 will remain everywhere. So 3 plus 2h by h, because negative I have taken outside and it gets cancelled from the denominator. So h tends to 0. When you apply 0, numerator will be 3. But what about 0 in the denominator? So it will not work. Similarly, if you do RHD, I've already done it. So I'm just claiming it's not going to work. For that, you have to do what? We have done in earlier questions also the same thing. So we have to check at minus 2 and 0. So fx is already there with us. What is this fx? Fx is 2x plus 3 and x plus 1 and x plus 2. Now f dash x, same here I'm going to find out. Okay. So this 2x plus 3 and the differentiation of 2x plus 3 is 2, x plus 1 is 1, x plus 2 is 1. That is d by dx I am finding out. For example, let me tell you about 2x plus 3, 2 d by dx of x and plus d by dx of 3. You know d by dx of 3 is 0, d by dx of x will be 1, so 2 will come. Similarly, 1 and 1 for the other two boundaries also. Now the range will remain same. Let me just call them as A, B, C. I would not like to write again. So this is A, B, C. Okay. Now left hand limit and right hand limit for the derivative we are going to find out. For f dash x, left hand derivative and right hand derivative we are going to compute. So x equals minus 2 will check, x equals 0 we are going to check. We cannot check for negative 3 and 1. And this left hand limit for the derivative, we are not going to write LHD, it is LHL for the derivative. So it will be limit x tends to minus 2, and here we'll write limit x tends to minus 2 plus, minus 2 minus and minus 2 plus. Okay. So when we have minus 2 minus, that is you are on the left of negative 2. So you have to take 2x plus 3 as the function and differentiation of that is 2. Because we are going to use a differentiation. On the right, when you take that will be 1. Because you are up ahead minus 2. So LHL and RHL for this derivative is 2 and 1. Because these are constants only. So they are not matching. So it is not differentiable at negative 2. Let us check at x equals to 0, LHL and RHL for the derivative, right? So x equals to 0, again same thing we are going to write, limit x tends to 0 minus, that is on the left of 0, and limit x tends to 0 plus, that is on the right of 0. So 0 minus, that is this x plus 1 function we have to use, but the derivative is 1, we already found out. And when we go up ahead 0, it's going to be x plus 2, but the derivative of x plus 2 is 1, which I told you just now. So when we find out the, there is no x, so even if you apply limit, doesn't matter, 1 and 1 will come on LHL and RHL. But they are same, they are exactly similar. That means that at x equals to 0, it will be differentiable. Write an example of a function which is everywhere continuous but fails to be differentiable exactly at 5 points. So there are various functions which we have already seen that they are continuous but they are not differentiable. But modulus x is a very safe function. We already know about it. So understand it very well because it is going to be used in the next question. Okay. So y equals x, when you have a line called y equals to x, it will be a straight line passing through the origin. But when you have the modulus, there will be no negative. That is, on the negative y quadrant, there will be nothing. It has to go to the positive quadrant. So because mod x will always give you positive result. So y will always be positive. There will be no negative y. So you have to take it up. So, it is continuous. You don't have to see y equals mod x, 5 points, mod x is there, so you just add 1, mod x plus 1. You can add my mod x plus 2, x plus 3 and x plus 4 just to make these as 5 points. So this is the best function which we can come up with. And so this is continuous. Continuous means that you don't have to pick your pen up anytime. So you are just drawing it and you can draw it. So this is continuous. Differentiable means at particular point the m or tan theta should not change. So this is the these are the concept behind it. See, you can also take x minus 1, x minus 2, x minus 3, x minus 4. That is the same thing. So let me just give you a more idea about it if sometimes this kind of question comes. Y equals x minus 1. That is the second term I am taking. When x is 0, y is minus 1. Y is going to be negative 1. Okay. And when we take y equals x minus 1, that is, when you take modulus, it is going to go up. But when y is 0, x is going to be 1. Okay. Y is 0, that is x-axis. X is going to be 1. So we are talking about this. So this is not the actual point. This is not the actual point. This will be the actual graph for x plus 2. And similarly, you have again this one x minus 2, x minus 3, x minus 4. So this is how you can comprehend why we have used this. Discuss the continuity and differentiability of fx. And this is log. See, first is the modulus. Inside that we have log, inside that we have modulus x. So there are multiple things which are going on here. So all of the thing is modulus x we know till now. We have done a fair number of questions. What about log? If you are aware of log, then only you will be able to appreciate and solve this question. So you need to learn and you need to be aware of log. Okay. So this is the solution which I presented for those who don't want to, see the solution. They can just have a look and a reference and they can do it. But for those who need help, this is the log function. So this is the graph and you know about this graph. See, log x is nothing but, if log x equals to y, say, and base is e, base is very important. So it basically e raised to the power is x. This is the log. If you take the log of both sides, e raised y equals x, that first line will come. So when you draw the graph, it is going to cut the x-axis at 1, 0. That is how it changes. That is, when you are actually putting modulus, so you cannot go to the negative y-axis. You also always have to come to the positive y-axis. The modulus will always give you positive result. This is normal log x. So the line which is below the x-axis, that is to the negative y-axis, won't work. That is, if you take log x or log minus x, log x you saw the function, and log minus x will be what? The same function mirror image on the left hand side. That is, log x, this is negative x-axis. So positive x-axis log x, negative x-axis it is log minus x. So same function will be, same graph will be drawn, but on the opposite side. Okay. I must tell you, you need to know log before going to solve this question. Okay. So now here we have, I hope you got the idea of log x function and log minus x function. But this question, there will be certain points where I am going to do something. Beforehand, I would like to explain it. See, when you put a modulus sign, I told you just now in one of the question, or otherwise, y equals modulus x. When you have y equals x, there will be a line, straight line passing through the origin. But when you have y equals modulus x, there will be no negative value. So that particular line below has to go up. So these lines which are going below, they have to come up for log x. Here like this. Same line which you show here, see here, it will go up. Okay. And don't worry about my handwriting. It's terrible, and drawing most terrible. Okay. So now this line, the line which is below has to go up because we have put a modulus. Modulus will always give you positive results. So positive y-axis you will get. No negative y-axis. So this line, just cancel it out. It has to be made up. Similarly, here also on the left hand side, the negative side, you have to clean it off because you are putting a modulus now. And it has to go up. So in order to make this has to go up, we have to multiply it by negative sign. That is what we are going to do. So 1, 0 and minus 1, 0 are the points which are of our concern. But this graph is going till infinity. We don't know where it goes. So we have to talk about and to take into account negative infinity and infinity also. So minus infinity to negative 1, negative 1 to 0, 0 to 1 and 1 to infinity. These are the 4 partitions or 4 you can say intervals which we have to imbibe, which we have to consider. Without that, we will not be able to solve this 2 modulus and log question. So I'm just clearing it up. Let us solve the question now. I hope you have got the enough base so that you understand this question, how we are going to solve it. So mod x first. What is mod x? Modulus x will always give you positive result. It will be x if x is greater than or equal to 0. If x is less than 0, it is negative. So you have to put a negative in front of it. So in order to make it positive, so it will be negative x. This we have done 100 times. But I told you with the graph that you have to consider there are certain intervals that you have to add. You just can't say greater than 0 or less than 0. No. You have to divide this modulus x result in 4 intervals. Negative 1 to 0, 0 to 1, but 1 to infinity and minus infinity to negative 1 also has to be included. But whatever is below 0, it is going to be x. Whatever is above 0, it is going to be negative x. It will remain same. It doesn't matter. Just interval we have increased, but the points are same. We know for mod x, it will be x for anything which is 0 or greater than 0. So minus infinity to negative 1, for this left hand side, since it is going to be negative, so you have to put a negative sign here, negative x. Similarly, from minus 1 to 0, it will be again negative x. See, anything below 0 is going to be negative. Please remember that. Anything below 0 is negative. Negative x. So, this is negative x, which we have done in the previous one also. If you talk about whole interval from 0 to infinity, 0 to negative infinity, it will be negative. From minus infinity to minus 1 to 0, it will be minus x only. When you go above 0, so there are 2 intervals, 0 to 1. When you are between x is between 0 and 1, then you are going to get positive. X value is positive because x is positive in the number line you can see. So you have to write don't write positive, it will be x only. But when you go up 1 to infinity, again when you're going up 0, it will be positive. So 1 to infinity will always be positive, right? We are just making the intervals, more intervals, just to encompass that log version. This has been done for the log thing, okay? So this, I hope you got the idea. This is very important. This is very important. There is one more thing which is coming, but I'll just explain it. First thing is clear. Now next one is you have to put a log. So log is simply put log. Log is just like that. Just put log. So log of this, log of x. For all these 4 interval, we have just made it as log. It doesn't matter because there is no modulus, etc. But when you put a modulus in this log modulus x inside a modulus, it will behave like modulus x only. It will be negative, it will be positive. I told you whenever you put a modulus x, there will be no negative y value. So you have to put it, it has to be positive. So in order to make it positive, you have to multiply it by negative, minus. Here also, this graph is going below. But when you put a modulus, when you have to take it in the positive direction, positive y-axis, you have to multiply it with a negative. So when you whenever we apply the modulus, when we apply this modulus, what will happen? When modulus log modulus x, when we'll do, so what all will have a negative sign in front of it? Remember the graph, what point of graph was below the x-axis? It was from -1 to 0 and 0 to 1, because minus infinity to -1 was up, 1 to infinity was up, so you don't have to worry about that. Whatever is there, write it. But -1 to 0 and 0 to -1, I am placing a negative in front of it. This middle 2 1, -1 to 0, 0 to 1, -1, that is why where I have to put a negative sign. You have to put a negative sign. Got this? These are the 4 intervals we talked about. If you are well versed and you understood this, the question is easy like a cake. Okay? So we have to check the continuity, we have to check the differentiability for all these points. Basically, we have to check it for -1 and 0. Right? -1, 0 and 1. So you have to check it for -1, 0 and 1. You have to do it for all. Please remember. I'll do this for one of these. I'll leave it for others for you. So we are going to check the differentiability first. So differentiability, please remember there was what partitions? It is going to be -1, 0. Here it is going to be 1, 0. And so -1 will check and 1 will check. You can check at 0, but it's not going to give you anything because log 0 is undefined. Please remember. So don't check at 0. It is undefined already. You know it. So we will check at 1 and -1 only. So the formula for differentiability is simply fx minus fc by x minus c, limit x tends to c. So same thing we are going to apply here. We are going to check at -1, x equals, now on the left hand side of -1 is -1 minus h, and the right hand side of this -1 plus h. Okay, now -1 minus h. So you are going on the left of -1, so you have to follow this interval. So what function you have to use? Log minus x. I hope you got this idea. Log minus x. So log minus x, that is why we have replaced minus. What is fc? C is -1 here. Okay. So for -1 is what? The value of log, you have seen the graph also. At -1 and 1 it is 0. So it is going to be 0. Log 1 is actually 0. Log -1 is also 0. So you have -1 minus h in the denominator, plus 1. C is -1 here. So -h in the denominator. So we have to replace this x by -1 minus -1 minus h. So log. So minus 1 minus h, but it is negative also. I'll just change the sign because it is not x, it is negative x inside the log. And what is in the denominator? You have negative h. Okay. And same thing we are going to do on the right hand derivative also. But we know this log 1 plus x divided by x, limit x tends to 0, and this is going to be 1. We know already that. This is a rule, theorem. So since you have a negative here, I told you, let me just change the sign. So minus is there. So this will be simply 1 plus h in the numerator. Log 1 plus h. So this is log 1 plus h divided by negative h. So negative, you can just take an outside. It will be log 1 plus h by h, and you can just apply that rule or theorem. So log 1 plus h divided by h, you can just have a negative in front. Limit h tends to 0. Please remember, limit h tends to 0, you have to write at every step. Log 1 plus h by h is going to be 1, so it will be negative is already outside, so it is going to be negative 1. What about right hand derivative? X is equal to negative 1 plus h. Same thing we are going to do in place of fx, but the function will change. Why? Because you are on the right hand side of negative 1. So just see negative 1 to 0, that is the interval. You have to use minus log minus x. Minus log minus x. And what was fc? Of course, at minus x equal to minus 1, the y is going to be 0. So it is going to be 0. fc is 0. X minus c. So minus 1 plus h minus of minus 1, that is going to be plus 1. This gets cancelled. You have a h in the denominator. Limit h tends to 0, you have to write. Okay. I'm not writing it. You have to write. Limit h tends to 0 is everywhere in each step. Limit h tends to 0. Okay. Even if I forget, you have to write it. So now you have a minus. So you have minus 1 plus h. So it is minus x. So it is going to be 1 minus h. And denominator you have h. So limit h tends to 0. But we know that log 1 plus x by x is going to be 1. If you apply the limit h, this. So 1 minus h by minus h. So you just apply this. You need a negative in the denominator, so you have to have a negative in the numerator. So negative gets cancelled. Log 1 minus h by minus h, but this formula is going to be 1. This is going to be 1. Okay, now we have applied the limit. Left hand derivative came to be minus 1. Right hand derivative came to be 1. They are not equal. That means at x equals to minus 1, they are not differentiable. This function is not differentiable at x equals to minus 1. Now, I hope you will be able to do at x equals to 1. Okay? Because it will take a lot of time to actually solve it. But the idea I have given you, same way you have to follow this procedure. Because the main was finding out the first step, which I already did. Okay? Now, let us come to the continuity. So, continuity also you have to check at negative 1 and 0. You can also check at 0. 1, minus 1 and 0. But the problem is the log 0 is not defined. So you just have to check at negative 1 and 1. So let us check at x equals to minus 1 or 1. Differentiability we have already checked at x equals to negative 1. Right? So we have to check at negative 1 or 1. So let us check it at 1. The continuity. I will leave that x equals to minus 1 for you. That is why I show the answer also. So that if you have any trouble, you can just refer it. So this LHL and RHL. So limit x tends to 1 minus you can write. Limit x tends to 1 plus you can write here. Now what is the function? 1 minus 1 in the left of 1. So minus log x you are going to use. And 1 plus means 1 to infinity, this function you are going to use log x. Now since x tends to 1, since you have used the function, now just apply x equals 1 wherever x is there. We used to do 1 minus h, 1 plus h, that also you can do, but it will not be required here, because there will be no untoward value if you put x equals 1 anywhere. So minus log 1, here also log 1. So log 1 is 0. So minus 0 is 0. And log 1 here also 0. So the left hand limit is equal to right hand limit. So this function is continuous at x equals to 1. Right? X equals to -1, I'm leaving it for you. If you have any problem, the answer is in front of you. You can just have a reference here. This is the reference. Okay? I hope you got the idea. Okay, this question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.